Alrighty, welcome. Let's dive into another presentation I gave at a conference. So this time it was actually the View conference in Italy, just a few days ago. And I'm going to give the presentation to you as if you had been sitting in the audience. So same content, same full-length presentation. I would say enjoy. All right, let's get started. So the title of the presentation, Procedural Urban Environments, Challenges and Solutions. And this presentation was given at the View conference in Turin, Italy. My name is Matthias Bühler, and I'm the founder and CTO of Urban. I founded the company in 2017, and right at the moment we are 12 people. My background is in architecture, and I took my first 3D steps in about 1992, so quite some time ago. And over the last years, I've become more and more a specialist in the field of procedural urban modeling, and in that field, I am a specialist in a tool called City Engine. And I'm also a Gnomon workshop instructor, having made a training DVD about the tool City Engine, and we are going to hear more about this later on in the presentation, what it actually is. Sweet. And as a last job before I started Urban myself, I was working in visual effects, namely at Scanline Visual Effects in Vancouver. All right, as a company, what is it that we're doing? So we are specializing in the creation of 3D architecture and environments. So per se, we're not specifically a VFX company or a games company. We're rather working independent of the industries, because the tools and technologies are very, very similar between the industries. All right. So one of the biggest inspirations for me is actually coming from the visual effects industry, or to found a company. And that is the company called The Third Floor. And what they did is, in the typical visual effects workflow, where you start at the very beginning with concept art, pre-visualization, then starting to model things, doing effects, rendering, and so on and so on. What they actually took is, or made is, they decided to take just the previous component, take it out, and build an entire company around just this type of work. And that to me was very, very inspiring. And actually, I saw, or I decided, hey, we can do the same thing or we're trying to do exactly the same thing for architecture and 3D environments. Now, Urban is divided in two business units. There's Urban Solutions, as the name implies, doing or creating solutions for clients. And then on the other side, there is Urban Studios, where we are creating high quality, off-the-shelf 3D content. All right, now on the solution side, here's one example project that we've been working on for the city of Zurich. Here you see one screenshot from their website, where we have actually done quite a lot of technical consulting on the creation of, or on the integration of historic 3D models into their digital twin, the Zurich 4D. And then also specifically working on the creation of the procedural models, which they have been using for creating over 99% of the historic building replicas. And so this image here is when you directly load Zurich 4D from the website and then switch to the year 1800, and then let the data load. All right. Then also on the back end, because all of this data is now open data, open GIS data, and So we were able to then also take the data and help with some of the visualizations and create some static renderings and also some animations. Now, so the animations we've been working on so far is the year 1800, but then also 3000 BC, so that's literally 5,000 years ago. Less buildings back then, but go have a look at that project. And yeah, as the name implies, Zurich 4D, so there's a time component. There might also be more timestamps coming on, where we could or where we hopefully will be working again with the city of Zurich to create those replicas of the historic digital twin. Then on the studio side, we have the shop, just a simple screenshot here, where you have a huge amount of individually made high quality 3D buildings that you can get for different so-called platforms. That means for different tools. At the moment, we have Unity available, we have Unreal available, but very, very soon we're going to release versions for Blender, and more versions for other tools are also going to be available. Then a couple of examples here of assets that you can get. So this newspaper box, then a phone booth. And this image here, it's a little bit dated, this image here, but I still wanted to show it. So I'm not even sure which one is which, but I think the left one is Unity, and the right one is Redshift. Yeah, the left one has to be Unity because of the reflection map here. But yeah, so to basically prove that it's exactly the same content, it's exactly the same building definition that can be used in multiple tools. All right, so the content of the studio side is basically a tool agnostic building definition, because the focus we have definitely on the buildings, but the same is also true obviously for the assets. Now, the specific approach we took is to create the content for both worlds at the same time. And obviously there's the offline side of, let's say, that is very, very often used in, for example, visual effects or high-end visualizations in general. And there's the real-time kind of the game engine side that offers, let's say, more game experiences, or can be used for virtual productions or similar real-time applications, also VR and things like that. Now, as I mentioned before, at the moment we have importers for Unreal and Unity. So the content is actually sold directly in the native file format, so there's no more import needed. It's literally drag and drop into your system, and then maybe adapt a little bit the LOD settings. And then on the offline rendering side of things, we do have an internal version at the moment of Houdini with Redshift, which is also going to be released quite soon. Then Houdini with RenderMan, working on that also. Blender, as just mentioned a minute ago. And then there are more options possible. We could go to the Mayas, to the Maxes, to the Cinema 4Ds, and so on. So if you have specific wishes, let me know. All right, let's dive into the main part of the presentation. Let's talk about challenges of procedural urban environments and some solutions, or at least some proposed solutions, or what we are doing to solve them in our cases. Sweet. So let's talk about the goals of the presentation. It's the intention to give you some food for thought, and nice, and to give you also some inspiration of how you could potentially solve those things, and give you a little bit an idea on the managerial side and on the technical side of what to consider when you decide to dive into procedural urban environments. All right, then a note. So the presentation is industry agnostic. So it's more, let's say, on a theoretical level. So you can take the information and actually apply it, whether you're working in visual effects or in another field like games, because the core principles are pretty much exactly the same. One of the complications will be for games where you need levels of detail. That's going to be a bit more complicated, or quite a bit more complicated, but we are also going to address this in a few minutes. All right, first challenge: the camera distance and the degree of freedom. What does this mean? All right, so if you have a fixed shot in visual effects, then you have no interaction, or the viewer has no interaction in moving the camera. So if you're sitting, for example, in the cinema, the movie is playing and you cannot interact, at least not yet, or not in most movies, right? So the camera animation is decided for you. You have no way to move the camera. Now, if you are working on a game, you have pretty much, or depending on the modern 3D games, you have pretty much free navigation. And so what this would translate to, and there's a cool analogy to that, is the number of pixels in a movie is finite. So you can say the resolution of the frame of the movie multiplied by the length multiplied by the let's say 24 frames per second, or 48 for higher end movies, and that gives you the amount of pixels that the whole movie has. Now with a game, because you have complete freedom to look wherever you want and go or walk wherever you want, there's an infinite amount of pixels that you have to be able to control, right? Now, this heavily influences how you tackle the creation of the environment, right? And what the content is that you have to generate, because it might be visible. So let's look a little bit deeper into this. So if you have, for example, the bottom right here, you have the something that is very, very far away, and you don't need to move there with the camera. You can say, okay, photograph or matte painting, let's say a sky with a city in the background. That's good enough. It looks absolutely photoreal. Then if the content moves a little bit closer to the camera, you can work with, let's say, textured cubes or textured terrain. Then coming again closer, you need to already have some sort of rough building form with textured facades and roof furniture. So that's like AC units and water tanks and whatever. And potentially on facades, even also simple reflections in windows, for example, skyscrapers, right? But then if you're moving all the way up close to the camera, then you have to have pretty much everything in full 3D. So you need to have different building typologies, different facade patterns, dirt weathering, light sources, and so on and so on. So obviously there's this exponential amount of detail that you need to consider, and the closer the objects have to get to camera, the more complex it becomes. Right. All right. Now, really cool. I really like this picture here of the Griffith Observatory in Los Angeles. And let's say this were a visual effects shot for a movie, and you're panning just to the side in front of this observatory. Then obviously in this case the foreground would be 3D. The whole landmark itself would be 3D. But there, depending on the depth, it might actually, to get a little bit of a parallax effect, this might actually already work with either a couple of cards or simply 2 or 3 layers of a matte painting. And that would be it to create a shot like that. Now, or let's actually go back, right? Now, if this were a game like, for example, GTA 5, 6, 7, or 8 or something like that, where you can actually drive through all of the cities, obviously, you have to start about planning everything in detail. Cool. Now, let's talk about the granularity of proceduralism. What do I mean by that? So it's very common that people refer to the fact that a city was procedurally generated. Now that is sometimes a little bit, let's say, misleading, and the reason for that is, how far do you want to go, or how far does the proceduralism go in the sense of the granularity? A lot of the stuff can also be marketing, right? And one of the thoughts there is, if you say the city is fully procedural, what do you mean by that? Are the trees all completely fully procedurally generated also? Or if you have, let's say, containers, you have 5,000 containers in your 3D city. Are those procedurally modeled? And or all the other objects like cars, are the cars procedurally modeled? Every single building, right? It's the granularity needs to be very precise about what you mean by the city was created procedurally. And this is why I also added the point of marketing here, that quite often it's referred to that it was procedurally built, but not in how far. So you could say in by far most projects, it's never everything, completely everything is procedural, because very often some components are procedurally generated, but then there are lots of assets which are used, like, for example, cars. It doesn't make sense to create cars procedurally, at least if they have to be very realistic, right? Same with vegetation, unless your project is really focusing on highly realistic vegetation and with huge variation. Now, one example of that would be, let's say, Avatar 2, where they created immense amount of vegetation with a complete procedural system just for the vegetation. Going on, continuing in the direction of buildings and the architecture, obviously, if you are working already with assets which you're instancing and reusing, then you can do the same thing also with entire buildings or building parts, let's say facade modules or window modules, and roof geometries and all of those things. Just pulling the things in from a library and then procedurally creating a reassembly. All perfectly feasible. And how we are doing this in-house, we are going to showcase a couple of examples later on. So yeah, be mindful of the term procedural city. Cool. Then attribute control and art direction. The idea of a procedural system is obviously that you can create lots and lots of variations that all obey the same rules. So in this case here, if we are looking at the Candler building, we would like to, let's say, create different buildings, many different buildings that have a very similar vibe, like the Candler building itself here. So looking at possible control attributes that we have to implement in a procedural system would be what is the building height? As a very, if we were just able to control one attribute, we would choose, for example, building height. Sweet. Then the system creates a building. All right. But going into the direction of making art direction possible, having control over certain things, we need to actually add more controls. Let's go further. Right. So you could say, instead of just using the building height as an attribute, you could say we're going to choose the number of floors and the floor height as attributes. A little bit more. Then you could continue, obviously. Number of base floors, that's at the moment 2, these guys here. Then number of top floors, at the moment here 3. It could be 5, right? Ground floor height and so on. You get the point. Now moving to another point here is where it gets a little bit more complicated is window types and widths. So if you're going into the photograph and if you're analyzing it, you will see that there are many different types of windows. Let's say these two, this one is slightly different. This one has kind of 3, let's say, wings. And then up here we have a smaller window with a round arc or with an arc on top, a bigger one without the arc on top, right? So those assets somehow need to be, first of all, made and then controlled. Same thing also with the distancing between the assets. And then also the columns and pillars. So let's find some of those down here. It's an interesting detail here, for example, right? There's only one column here and here, right next to this main entry door here. But maybe we would want to control if there's also a column placed here and here. Right? More control attributes that need to be definable or settable from an artist perspective. All right, then decor, you see all the elements up here, and then the whole facade patterns. Down here, there's a facade pattern, then there's even this little protruding volume here in the middle. Then this pattern here, two small windows, 3 bigger windows, symmetric placement, and so on and so on. Now, we have just looked at the front facade of the building, right? If you're looking at the side facade, works partly the same, but maybe you would want to go in and actually be able to define what the patterns are, or where the columns are, or what the window types are also on the side facade, or let's say per building side. Now you see, at some point, if you have to design just 10 or 20 buildings, just you trying to go in, or an art director telling you to control all aspects of a procedural building, will actually take you longer to, first of all, implement all of those controls and different mechanisms, and going in and setting hundreds and hundreds and hundreds of attributes for all of those facade sides. But this in itself will take you much longer than to create the building just manually, right? And so there's a sweet spot between control and automation that you need to consider when you're designing the whole procedural system. And you need to have the goal very clearly in mind, and a very honest dialogue, or a very well-controlled dialogue between what type of control is actually needed for the project at hand. Yeah, let's move on. All right. So let's say you have one wall and you have one door that you can place in the wall. How many variations can you create? Infinite, right? So you can place it on the left side, you can place it on the right side, you can place it in the middle, wherever. Infinite variation. And this in itself, this just first little super simple example proves already that creating architecture procedurally by definition creates an infinite possible amount of variation that you have to control. Now, that was just with one door, right? So if you're adding more elements, let's say, for example, this window module, let's say this window module, it gets even more complicated, or a lot more complicated. So let's say you have you're creating a 3D game that has altogether five doors and 10 windows. That already you can create an enormous amount of variation, but you can say, okay, the system is relatively simple, because you can say, okay, this certain arrangements are more feasible, the others you can drop. Now, but the problem is, the more assets you're adding, let's say the little windows here, the vents and so on, it gets a lot more complicated. And I snuck this guy in here, the ATM. I think I've never seen, and this doesn't exist, that there's an ATM right on top of a little window, on top of a little vent, right? This situation, because it's also too high up to actually interact with the ATM. And all of this information has to somehow be stored in a system, so that the procedural system, when it creates architecture, when it creates facades, it actually has to know all of these things. The computers are dumb, right? So we have to tell them what is architecturally feasible and what isn't. And this is something that is a gigantic challenge to control. But the first step is to even be aware of this challenge. All right, moving on. Next challenge, building typologies. So here we have again our little Candler building here, procedurally built in City Engine. And then there's the Parthenon temple. Now, one thing that is actually a fact that sometimes people do not understand or do not know is that different types of architectures work completely differently. So if you're looking at the Candler building here, it can be procedurally built based on a footprint. So that's a 2D polygon. And then we are extruding it to this volume. And then we're going to cut, let's say, these borders out. We're going to split the facade, and then we're going to insert certain windows and windows patterns, and on top we're, let's say, distributing some assets. Perfectly feasible way to approach this. But from this logical system of modeling steps, there is no way how you can, for example, generate a temple geometry, because it's built completely differently. So there you are going from a footprint to, let's say, the main volume here. You're adding this hip roof on top, a couple of steps on the outside, and then from going kind of from volumetrically from the outside towards the inside, you're adding a inner volume, and then these colonnades that you then, for example, replace with actual 3D assets. So the building typology is completely differently built. And now the statement is, or the core message is, that if you have a procedural system, it typically, very, very typically, actually reflects just one very dominant building type that your city needs. But in reality, that is not very often the case, because you have in a real city, you have many building types, and so that would mean that you have to have like an uber procedural system that can create all of those different building types, which is incredibly complicated. and also would cost way too much to develop if you're looking at, for example, the list of attributes we just saw before. And usually, especially when storytelling, or for example in the film industry, you want to sell a specific story of, for example, where the story plays, let's say Paris. And Paris has a very, very specific type of architecture that is, when you see it, you can automatically say, okay, the story is actually playing in Paris. Then let's say in the background there's the Eiffel Tower and everything is clear, right? So you don't need, for storytelling reasons, there's not necessarily a need to create many, many different building typologies. But the more realistic you want to recreate a city, the more details you actually have to nail and be precise about, right? So converting one procedural system to another one is just usually not possible. All right, one example of a city that was created with just one building typology is this project here, the favela, which I made together with a friend of mine and a coworker, Cyril Oberhansley. The favela that you see here is basically just one building type, one archetype, but in many, many, many different variations, procedurally built. Let's talk about architectural consistency. So one of the, at least to me personally, one of the most important aspects of realistic architecture, and that is a huge challenge especially when creating it architecturally, is that the architecture is consistent in the sense of an architectural consistency. I just going to explain with a couple of images here. So the building has to feel realistic and work. Let's say the roof construction here with the little details of the borders, for example. Then moving on here, it might not be visible very in detail, but there are doors actually leading to these open space areas. There's a realistic distribution of assets that might even include, let's say, pipes or vents or things like that. Same thing also here, where there is actually a door leading to those open areas for servicing. Same thing also here on the other side, on this left image here, where there's also a realistic distribution of the infrastructural elements, let's say cooling units or AC units and water tanks in the right type of placement in a architectural meaningful or consistent way. Now, this stuff is incredibly complicated, and sure, we are trying to go the extra step there, the extra mile, but it's to me personally, this is a challenge, and I love trying to solve these problems. And in the end, obviously, the result is just much more convincing than just negating these issues. And in a lot of projects, 3D projects, where you actually see buildings, let's say, that are fully procedurally built or created, a lot of those details are actually completely neglected. So let's say larger roof areas, let's say, for example, this area here, wouldn't even have a single door to actually access it. Now, sure, if you're creating, for example, a racing game, and you will never see those aspects or those parts because you're just driving on the street, it's absolutely perfectly feasible to leave all of those details away. But then coming back, for example, to a helicopter game, if you would want to take an existing procedural system and improve the quality, you would need to go in and try and solve all of those little issues and details and actually trying to massage those into the procedural system. And that's just a heck of a lot of work. And so we're in-house, we're working on systems to actually do this from the get-go. Cool. Then urban context. Now, architecture and urban planning are silent actors. What does this mean? If you're telling a story, then you need to have a realistic backdrop. You need to have a realistic, let's say, set. And for a lot of projects, the architecture needs to be spot on to feel that when the story is being told, that the architecture actually reflects the world that is described. Very often a mismatch in that can actually take you out of the immersion of the story. Same thing also with urban planning. If the street widths, if the in general the street furniture, if all of those things are not solved properly, especially on large scale environments, the immersion in the environment is actually, let's say, hindered. Massive challenges, but you need to be aware of it. Then, yeah, we just talked also about street. Obviously, there are different street types, from highways to boulevards, and then also they are dictating the centrality. For example, where are you in a city? Are you more on the outskirts or in the suburbs even, or are you downtown? And a lot of elements like street widths reflect this very, very well. So let's look at a real-world tool that is used to describe those things. Let's say the centrality or an integration value. So the image that we're looking at here is from Wikipedia. It's showing a colored image of some street center lines, and let's say the algorithm is called space syntax. Now, what is space syntax computing? What it's doing is basically calculating how well certain points of a city are based on the city's street network, how well they are, let's say, integrated. Blue is not well integrated, and red is very, very well integrated. And the funny thing is actually the algorithm, or the way how streets are built in reality and how wide they are, that is very heavily influenced by human psychology, with tendencies that you would rather like to go longer and faster straight on, and then take hard turns to get to a location, than to meander further in navigation through a city. That's, I don't know why, but that seems to be deeply rooted, or that is deeply rooted in human, let's say, navigation behavior. And that can be simulated, for example, with this space syntax algorithm. And you see that longer streets that are straight become much, much more important for navigation. And the funny thing is, if you're matching let's say the color values to actual street widths in reality, they actually correlate pretty much perfectly. So that would mean red streets here are very wide, have a lot of lanes, and blue ones here maybe just have 2 lanes, or potentially even 1. So that's something that is very, very interesting, and I think has to be considered when creating realistic cities, especially procedurally. Cool. Then the formulation of different city parts is also something that is obviously important, that you feel that things are designed, and that they actually have to do with If something is more central, you would have less, let's say, forest, but maybe you have little parks with water bodies. And when building procedural cities, I think it's not always just procedurally creating realistic architecture or distributing architecture realistically. It's also about adding all of these little details in how do you formulate the different city parts and the distribution of the objects in, let's say, rural parts or residential parts or commercial parts of a city usually work completely differently. And you see, the more you want to control those things, the more efforts you have to put into the procedural systems. Cool. So let's briefly talk about City Engine. We mentioned it at the very beginning. So how does it work? This is an older video I made some time ago, but it shows very beautifully that it has a centerline based system called dynamic city layouts that allows you to move and edit streets, make them wider also. And then the system actually computes the block subdivision and then procedurally on top of those shapes, depending on if it's street shapes or lots, that means parcels, you can then assign different procedural rules to have the urban fabric generated. So as we are using this system, City Engine internally quite intensely, we have gone in and created multiple distribution types, procedural distribution types. So we have industrial parts, we have residential parts, we have commercial parts, and then downtown. Next to those, obviously, also there's more open space or definitions for open space and also for the streetscapes themselves. So when, for example, designing a completely fictional city like that, we are designing all the street widths in City Engine, and then we are actually going in and we are saying, okay, where are the open spaces, where is downtown, where is commercial areas, and where are residential areas. And then with this definition, out of that, obviously, you are getting a complete 3D environment, which in our case, we're exporting and, for example, rendering a package, or we're moving it over to a game engine for, let's say, for a racing game. Sweet. A quick turntable here, a section of a suburb. This one here was also, like as just described before, created with the residential rule, just a couple of streets. They seem to be a little bit overly wide, but just to prove the point. And then this was actually rendered in Houdini with Redshift. Cool. Moving on to a little bit bigger scales. Now, this is a project called Utopian Disruption, which we created together with our friends at the Ideal Spaces Working Group. So that's idealspaces.org if you want to go to their website. And the city here has about, let's say, the diameter or the distance from here to over here is about 7 kilometers. That's approximately 5 miles. So it's a pretty big project. And the representation here you see is just a preview in City Engine again. Zooming in a little bit, using some of our buildings that we are actually selling on the shop. And then this project was all about coming up with an ideal city context and especially concept. And then rendered again also the project with Houdini and Redshift. Then different project. Uh, Same methodology, also created in City Engine, rendered in Houdini with Redshift. This one here is a city that has a radius of about 7 kilometers. So that's about also 5 miles, obviously. And you see that we can go, I would say, pretty big with these workflows, and we are constantly improving them as we go. Sweet. Now, we talked a lot about the challenges so far because it's the topic of the presentation of doing everything fully procedurally. Now, from this point on forward in the presentation, there is a reason why, or I'm going to talk about our building content that is on the shop and why, and I'm going to explain why we are creating the buildings not fully procedural. Those are technical challenges that you need to absolutely consider if you decide to go, sorry, if you decide to go fully procedural. So let's dive into the details or into more details. All right. So the first topic here is offline rendering versus real-time rendering. Obviously, this has to do with optimization. In the film industry, for example, talking about virtual production, you may have heard about this topic. Now, virtual production relies heavily on real-time performance. So this is one of the reasons also why our content is actually very specifically designed so it can be loaded into game engines with the according optimizations to make the content real-time capable. These optimizations have to do obviously with the performance. So the goal is for offline rendering, for real-time rendering, to have as many frames per second as possible. Graphics performance, very, very high graphics performance. Now, there is this concept, for example, of the draw call optimization. That means minimizing also the numbers of material that the game engine actually has to render or visualize at the same time. So the FPS and the number of draw calls are some of those are the best, let's say, indicators of performance of your game level, how well it performs. Then to actually push these things, you also can go further with texture optimizations. In our case, what we have is texture atlases that are fully PBR. That means we have textures for the albedo color, that's kind of the main material color. Then roughness, which correlates to reflectiveness. Then opacity, transparency, metallicness, normal maps, and so on. So the full PBR realistic material definition. And actually, they are atlased so that we're trying to combine as many of the textures into atlases so that the game engine has to load as few individual files as possible. Then that's also something that we're doing is, for example, unused color channels. That's something that is very, very often done for optimizing in games, is to actually take grayscale information, let's say pure grayscale information like metallicness or, for example, or opacity, and then actually, instead of having those as separate RGB textures where you have the same information in one file, you're actually trying to go in and merge multiple of those grayscale textures basically into fewer files by filling them into R, G, B, and then potentially even A, the mask or the alpha channel, right? To compress everything into as few files as possible. Then you also have obviously the whole discussion with whether your normals should be 8-bit or 16-bit to create as little data as possible. And this is a huge rabbit hole. This we spent a long time just on optimizing those things for our content. All right, let's continue talking about interiors. So because we're talking about urban environments, we are going to just keep talking about the use case of exteriors, external views of buildings and urban cityscapes, but not actually going into the buildings. All right, but still looking at buildings from the outside, you will see interiors if you come close up to windows, especially with skyscrapers. And if you want this to actually look realistic, you need to have some sort of representation of interiors. And there are different types. So you could say you want to have in a game, for example, fully 3D enterable interiors or buildings, including all the cores for the navigation, let's say the elevators and the staircases and so on. So this is, we know these things exist, obviously, but we're not going to focus on those because you would need to absolutely procedurally create everything, including solving the full navigation, elevators, and so on, right? You see how far this can go if you want. Then another thing that is quite commonly used is to use full 3D pseudo interiors, where you're basically just taking the whole volume of the building and you're cutting it into floors. And then you take each of those floor volumes, you take the floor polygon that is cut through, and you start adding, let's say with some offsets, you're starting to add 3D elements like, for example, offices or restaurants as simplified 3D geometries because maybe you don't need to see everything absolutely close up. That's again a distance question for your specific project, right? Simplification. Then you can go one step further and you can say, okay, we're going to create some sort of 3D representation that is not just cutting through the entire floor of the building, but just gives you a certain depth inset away from the facade, where you create some rooms and you're adding some actual 3D objects behind a transparent glass. Also very, very common technique or technology, or especially on the offline rendering side of things, sometimes also for games, but obviously you need to have all of the 3D objects and load them fully. So you need to be aware of those mechanics. Then there's also this technology or technique called procedural parallax occlusion. And that's actually the solution that we are using in-house. And I'm going to elaborate a little bit more on this. So let's talk a little bit about the quality of the interiors. So one of the aspects is also, if you're looking at a building, let's say a skyscraper, there is a very strong tendency that, for example, restaurants and let's say shopping mall entries are only at the ground floor. So looking at the interiors or the interior design of the ground floor, you need to have a certain usage distribution, so that, let's say, commercial or restaurant or things like that, they're usually only at the base floor. So this needs to be controlled. Then upper floors could be, I don't know, hotel, could be offices, whatever it is. And looking at the skyscraper from a distance, if this is not controlled, especially in a night shot or in a night scenario, if you see the color patterns are not correct, the emission light or the emission intensities of the interiors, if those are not right, it just is, it doesn't look realistic. So it has to do with the visual quality of, if, and mentioned also before with the architectural consistency, if the buildings actually feel realistic, even though if you cannot even specifically state what it is that that doesn't feel absolutely realistic. So the distribution of the usages of the texturing or of the 3D interiors that you're building on a per floor level. Then another challenge is also we fell into this pitfall, into this trap, is that you can have the situation where you have multiple windows actually showing the same room. Let's say you have a big office room, 12 meters, whatever that is in feet, 12, let's say 30, 40 feet, something like that. And then you have a glass facade and multiple different polygons, but you're looking into exactly the same room. Now, this is something that on the UV mapping, on laying out the textures, for example, or looking into room, is something that has to be spot on, because if you're looking at a skyscraper that has just cubic rooms, 3 by 3 meters, 4 by 4 meters, especially at night, you see repeats of just boxes. Looks absolutely unrealistic, because, or if you say, for example, one windows is one room, you need to be able to control that there are actually bigger rooms that don't just have absolutely random color emissions right next to each other. Needs to be managed, right? Cool. And then also, obviously, last but not least, the interiors, the closer you come to the project, to the building, and this obviously depends on the project, you need to have more and more realistic designs of the interiors. Cool. And then one of my pet peeves are, as you might have gotten from the rest of the explanation, is text repeats. This might be okay for certain games, and you see this still nowadays. You see a lot of text repeats in interiors of buildings that just somehow have to be optimized. But in film, for example, this is unacceptable. Because it completely kills the immersion in the story. So that is something that we internally are investing heavily into, removing any potential or as many text repeats as humanly possible to make the content still real-time capable. All right. Then another aspect of how you're creating the interiors. Do you create them kind of, let's say, fully 3D or pseudo 3D, or with an inset, but you're actually distributing 3D assets, let's say windows and lamps and desks and all of that stuff. There's a decision that you need to do or to make. How do you actually ship this content as 3D objects, so that you have literally you have a transparent glass and you can see inside the room? But if you're, for example, shipping the content to another client who renders the project, you need to decide, does this stuff need to be in 3D? Or in our case, we're going to look deeper into this. That's a very specific reason why we chose parallax occlusion as a technique, because in the end, what we're compressing the 3D interiors into single texture maps that give you the illusion of a 3D interior. The reason for that, and this is why this point that I'm talking about here, is the IP legals. If you're bringing over the content of your 3D buildings to another client, or if you're pushing it to another studio, or if you're selling, for example, a procedural system to another client, they need to have all the licenses to all of the content that is used. Now, seeing, for example, if you have lots and lots and lots of different 3D interiors in your city, you need, this can be hundreds of or thousands of dollars of just getting the same licenses to use the content for that said procedural system. This is a challenge. And we are specifically addressing this by saying we don't, first of all, for optimization reasons, in the sense of real-time performance, of tracking these things or baking these things down into textures, first of all, but also to make sure that our clients have absolute green light on the legal side, because we are controlling the full, complete IP of the whole building, including kind of the interiors. It's a little detail, but I think it's really, really important to be aware of the legals, because especially in with larger movie productions or larger, let's say, render budgets, this can create lawsuits that are really gnarly. All right. So what is parallax occlusion? Let's actually have a look at this. And the video is going to repeat a couple of times. But so what you see in the windows, the inner room is actually, there's nothing 3D. It's just a material effect. It's a mathematical illusion. And you actually see this at the very beginning, and we specifically recorded this also, that you see there is no depth to this facade. So the main facade polygon, the gray polygon, actually has no thickness, right? And so this is the beauty of this effect. It's only texture based. It has a lot of, let's say, mathematical computations of which pixels actually correspond to which ray direction and the UV location. But it gives a very, very convincing effect of a 3D interior. Then going on, obviously, we needed to, because we want to control our textures for this, for our own procedural, parallax occlusion system. So we needed to create rooms that we can actually kind of package into those parallax occlusion textures. And for this, our artists actually went in and created about 650 completely detailed 3D interiors, which you see here, in a lot of different styles. So we have industrial interiors, we have residential, we have hotels, we have cafes, we have everything, it seems. And then here is an example of how this looks with or visualized actually in the Unity game engine. Just one example here. All right. And or actually let me underline this here, right? If you want to have highly realistic looking 3D buildings that can be used in a, for example, in a photorealistic visualization or in a photorealistic game, if you want to come close up, let's say you have a skateboarding game or a racing game or car visualizations, for example, chasing through the city, you want the textures inside the rooms to be as realistic as possible, and especially at night, because that's when you see most of the interiors, especially also if you're looking up on skyscrapers. We will see an example in a minute. So planning all of those things for a real-time context is a lot of work. It's actually already the next image, right? So again, this image here, this one was actually made in Unreal. And you see all the little details of the roof lights on the ceilings in those virtual parallax occlusion based interiors. Same thing also with the usage distribution of that. It's a realistic usage actually applied to all of those rooms, and what you will also say is a very realistic distribution of that. Sometimes some of those floors actually have no light whatsoever. Let's talk about emission at night. So, talking about the complexities of optimizing all different effects for as realistic visualizations of buildings, it might actually be the case that our clients, for example, would want to animate a sunset over a city. And so in such a scenario, you don't have just bam and the city has lights turned on everywhere. This is not how it happens in reality. So in our case, we have different materials that we can activate with sliders, or let's say emission intensities, that allow you to animate these things on a per building level granularity. And so, for example, in both Unity and Unreal, even if you would have an identical instance of a building, you might want to actually drive both emissions, or the emissions of both buildings, completely individually. So this somehow needs to be solved, and we actually did solve it. Yeah. All right. Let's look at an example. So this animation here is one of our skyscrapers, and the animation is actually rendered in Unity. It's a massive building. Another little detail, just in case you might have missed, also look at that the glasses are actually bent. These are the normals we mentioned before. And another element also that we have is that sometimes for some of the floors, actually these the shutters are closed or half closed. So that's also something that tremendously helps realism, because that's just how people interact in those rooms in reality. So we try to mimic this behavior. Cool. All right. Then this is an interesting slide which I just wanted to add. It's one of our testing slides where we are using RenderMan in Houdini to render this image. So we're working on an importer for RenderMan for Houdini. Now, it's exactly the same system as mentioned before, based on exactly the same textures and the materials and emission. Now, one thing that was actually very, very interesting to see is that the solution has a light transport that considers the orientation of the interior rooms. So what's happening here, and you see this, is that first of all, obviously, if the room is more, let's say, blue, obviously the bleeding light coming out through the global illumination simulation of rendering it will, let's say, create more blue tinted light that hits the floor, or the kind of the rest of the city coming out of the room. But what's very, very interesting is actually that you see there are certain, let's say, light circles that are happening here. These are actually very interesting effects. So let's say if you have a room that has a gray back wall, and then you have the right wall looking outside is red and the left wall is blue. Now, depending on where you are standing on the outside of the building and would look on the floor and see what are the where does which light go, you will see that the reflection of the right red wall will actually kind of through the natural light transport bleed more onto the left of the room to the outside. And vice versa, the blue wall will bleed more to the right side. And these are exactly the effects that we see out here, which are physically correct. And this was a little bit mind-bending to see that this is actually kind of, even because it's just a virtual room, right? We don't have any geometry there. It's just a shader-based system, but that even the light transport works. So that's really, really cool. Then this is another image that we made that, and the context here is the image is made in Unreal Engine. So Unreal Engine is a game engine. And because of these things, we needed to say, okay, or it's actually very common that game engines only render what you see. Now, it can actually happen that, let's say, if you have a reflection of the other side of the building in a skyscraper here. So it could be if that, depending on which game engine you're using, it will not actually show these the backside because you're not specifically looking at that other geometry because it's hidden. So one of the terminologies there is backface culling, for example, or just there are also other techniques like occlusion culling and so on to basically hide everything that you don't see. But the point why we specifically wanted to test this is that even though that you have reflections, now these are ray traced here in Unreal, but the challenge is that the shader, the parallax occlusion shader, actually has to work geometrically correct even in reflections. So what we, right, so we have a big glass facade here, but the ray direction is first of all reflected in the skyscraper, and then it's actually showing the reflection of the virtual parallax occlusion interior on the other side of the on the building here. And everything, all the vector math actually has to work completely correctly so that you don't get any weird distortions, right? So we needed to solve all of those things, and it works. Cool. Now just this last little detail which I just mentioned, and also mentioning again that the content that we are creating is tool agnostic. So to whichever tool we are bringing in our content in, they might have different coordinate systems. So let's say Maya has a y-up coordinate system, handedness, I don't know, but they might change, right? Then Houdini has a coordinate system, Unity has another coordinate system, Unreal has z-up, and yet another coordinate system. So all of those elements need to be absolutely considered also, or first of all for all of the geometries, obviously, but then also for all of the shading of the parallax occlusion systems. Cool. Next challenge for procedurally building buildings and environments are LODs. This is especially important for game engines, so for real-time applications. Now, I've been asked a lot of times that if we are building procedural buildings, if they can be directly optimized for games. And the typical answer to that is no, because you have a lot of extra optimization steps that just cannot work just purely in real time. But let's dive a little bit deeper into LODs. So I'm going to show you the 5 LODs now, which we are typically creating with all of the buildings we are creating. So of the 5 LODs, LOD 0, the one which we see here, is typically just for offline rendering, highest quality. And then the other 4 we are using in an LOD system for the game engines. Now here we are actually visualizing all 5 LODs in Unity. So let's cycle between the LODs. So LOD 0, highest. LOD 1 actually has about 50% of what we just saw before. So I'm going to toggle. Let's go back to LOD 0, 1, 0, 1. Again, about the 50% reduction. Then going on to LOD 2 is a lot less polygons. Again, and then LOD 3, that's very common, the imposter, and then LOD 4 for very, very far distance cards that are typically orienting themselves towards the camera. Let's step again through it. LOD 0, LOD 1, you see just a marginal switch, and then going to LOD 2, here it's actually getting very, very interesting, and especially regarding, you can see it actually here. This vent here still has the full metallicness information of the high quality object. It's actually because this one is flipped, right? But you still have the full PBR material definition that includes albedo, normal map, let's say reflectivity, roughness, and all of those things are actually baked down into those textures. And this is not something that you can typically do on the fly. This takes calculation time. And then another aspect I mentioned also before is the so-called draw call optimization for game engines. That's reducing the number of materials. So if a building like this has, let's say, 20 or 30 or 40 different materials, this means 20, 30, 40 or 50 draw calls. Now, switching from LOD 1 to LOD 2, in this case, here we have baked everything down fully PBR, but into one draw call. This is a huge optimization step. And now considering that you have, for example, a complex interior that you're showing, we saw the bicycle before, right? You have to absolutely make sure that there is no jumping in the look, or there's no pop basically in the look of what you would see in the high LOD, let's say LOD 1, to the lower LOD. So all the crunching together, all the merging of the materials into lower LODs of a system that is actually fully parallax occlusion capable, that's a huge technical challenge, right? And why are we doing this? Well, because we need to do it for all of the LODs. All right, let's move on from LODs. Let's talk a little bit about the thoughts of why we just mentioned all of those extra steps that we're taking for our content for the buildings. So first of all, our buildings are, as mentioned, tool agnostic. So we have to have let's say a geometry and a texture representation of our assets, and especially the buildings, that is independent of whether we want to go into a standard 3D tool, let's say like Maya Max and so on, or into a game engine. Now, with all of the examples before, right, this shit is hard. But then also, why do we do it? Well, you could say we love this shit, right? But also, it actually allows us to take the same content and push it into multiple tools. So there's this notion of scalability and making it possible to share the same content into multiple companies, into multiple workflows, into multiple industries. But it uses the extra mile, obviously, or we are going the extra mile. Now, so altogether, why are we doing it? Because kind of or our clients actually will in the end have an easier time if it's made for them. Some of the steps that we just mentioned before, with visual effects studios, smaller ones and bigger ones, it's not every day that they have a 3D project or a project where they have to create a full 3D city. So bringing in the staff to create a 3D city from scratch, or maybe collaging it with existing assets, is quite a challenge. And sometimes, or more is demanded out of those productions. And this stuff is not easy to do, as we just saw in the last minutes or in the last half hour. So this is why we are doing this, to help you guys. All right, now on the business side, just to mention it regarding the environment creation, we might actually start licensing the environment creation workflow on the City Engine side. And then another aspect I just want to reiterate is everything that you've seen in the visualization so far of our content is fully our IP. The only exceptions are the trees and the cars. Everything else which you see is fully our IP. Now, the future. Where do we want to go? Well, there's a lot to come. So it's exciting. I'm really looking forward to the next steps and to the next couple of years. Sweet. So I want to leave you with a couple more impressions, a couple of pretty pictures of the stuff that we created in the last time. And yeah, let's dive in. All right. A couple of our skyscrapers. I would say, meanwhile, you could say film quality, actually visualized in Unreal Engine. Some of the details of one of those skyscrapers. So as you see here, you can go pretty far up close to the buildings, but again, they're real-time capable. Then showing an example of an environment. So the dimensions of this environment is about 3 by 3 kilometers. So that's about 2 by 2 miles. Left side, the raw layout in City Engine, as showed before in the little movie. And then on the right-hand side, the preview of the city generated with proxy geometries in City Engine. And from there, we can obviously export everything in our formats. In the example I'm going to show you is we just exported this part of the city in this case. So let's move on and show this. This is now the preview in Unreal. We weren't able at the moment, because this is all still work in progress, to export the whole 3 by 3 kilometers. So this is what worked so far. Again, work in progress. But this is, let's go back actually. You see the little waterways and the vegetation distribution and the parts of the city on the industrial side, but also on the residential side. So you can recognize those elements here. But let's move on and have a look at some views of another environment which we made and also visualized in Unreal Engine, just taking a little bit time to add in a little bit more atmosphere and set the sun angles nicely. Cool. Another view more in a residential area, suburbs. Another very cool camera. Then again, Unreal, real time. I love this stuff. Cool. And then also obviously because it's Unreal based or game engine based, we have the advantage to really quickly play with a lot of different things. Let's say with the sun position or the time of day, or also with the atmospheric effects. Let's say, for example, like the volumetric clouds that you see here, but also we can play with the weather in general, with all the content also having the sky system being linked to all of our materials, making everything appear wet, for example, or because we can also make it snow, right? This shows you a little bit the capabilities of these systems, and where all of these optimizations, specifically for game engines, become really handy, also in the context of, let's say, games or virtual production where you want to work fast. Yeah, that was it for the main presentation. Just a quick information about my own podcast, the 3D Environment Podcast, which I just started a couple of weeks back. Go have a look at it or have a listen to it at matthiasbühler.com. You will also find it on different of the bigger platform aggregators like Amazon Music, Apple Podcasts, Spotify, and a couple more. The podcast is also available on YouTube. So if you're interested, go have a look. Then also our website. It would be a pleasure if you would take the time to go have a look at www.vrbn.io. And with that, the presentation is concluded. There's no QA than we can do like at the View conference, and we got a bunch of questions there. But if you do have questions, please note them down in the comments of this YouTube video. Thank you so much for the time, and I hope you learned something. See you in the next video. Thank you so much.